Hello, my name is Kalind Carpenter. I'm a roboticist at the Jet Propulsion Laboratory, one of the NASA centers in Pasadena, California. I've loved space since I was 5 years old. I used to look up at the moon. I could see all of the craters. I always wanted to explore it. I wanted to be an astronaut. I used to build Lego robots, Lego spaceships, and imagine just going all over the solar system. When I got older, I found that robotics was the path for me. While space isn't always friendly to humans, you can build a robot that is perfectly happy in most of the environments available within our solar system. Mars is one of our closest neighbors. It's a sister planet to Earth. It's technically in the habitable zone, same with Venus. So one of the questions we have now that we see all of the exoplanets around the stars all around us is, why does Earth have water on the surface and Venus and Mars doesn't? We need to be able to look with our next generation telescopes at them, where we'll actually be looking for the atmospheres. We're also looking to see if we can see the chemical signatures of life, something like photosynthesis might create, or other metabolic processes of life. So basically, is there things breathing and eating things that we know of that would change the chemistry in a way where we think that there's actually life there? So we've got these great questions. We know there's life on this planet, and there's been life here since the heavy bombardment was going on. At that point, you just had these big asteroids crashing into all of the planets in the solar system so hard that rocks would bounce off of them. We know we, to this day, get hit with tons of Mars, and likewise, Mars and Venus are getting hit with tons of Earth. So we know that some rocks with life on Earth have bounced off of Earth and probably hit both Venus and Mars, as well as further away. A lot of these are actually extremophiles that could still be alive. Is there life, or was there life, also on Venus and Mars, potentially elsewhere as well? Well, Venus is a very difficult place to explore. Mars is relatively benign, comparatively speaking, and we've had many missions that have gone there. When we first went there, we expected to actually find water because we could see with our telescopes what looked like canyons and valleys. We were surprised to find what seemed to be a dead planet with the early Viking missions. Even then, though, we were looking for life, but we didn't even have a definition of life or how you might want to look for it. So there was some flaws with the instruments that we sent and their ability to really tell us what we were seeing. There are some scientists that think we saw signs there, but the chemistry on Mars is very different. So that means you have things that actually eat organics. These things are called perchlorates, and they're all over the surface. So that means on the surface, it's hard to actually tell if there's any organics. But when we started sending our rovers, the one right before the Perseverance rover that we just launched, the Curiosity rover, which I have on my shirt right here, one of the first things it found is that Mars was covered with lots of water. In fact, it found big round boulders that only could have been rounded if they had actually been carried by water. So we knew that there was water there, and how much water. Then it started taking samples, and it found fresh water, it found salty water, water very much like you have here on Earth. So this begs the question, when there was water there, when there was water that life here on Earth could have lived in, was there life there? So the Perseverance rover is actually going to try to answer some of these questions. So we actually want to land on Mars, and the Perseverance rover is landing in a place called the Jezero crater that used to be filled with water. It was about the size of Lake Tahoe, and it has these fans, these alluvial fans, where these rivers actually just had all of the rocks come out, and you can see the path of the water. So we imagine there's probably sedimentary rock. That's where we find fossils here on Earth. Regardless, it's going to be a very interesting place that tells us a lot about the history of Mars, but it's also one that may actually yield signs that there was once life there. So we'll actually be drilling down into this rock, and then we're going to take those and we're going to seal them completely so nothing can escape. Leave them on the surface. Then another rover is going to come, the Fetch rover, and the Fetch rover is going to pick those up, put them in a rocket. That rocket's going to fly up into orbit around Mars, and it's going to release all the samples, which will be in something about the size of a basketball. Then we've got to capture that basketball in orbit around Mars and bring it back to Earth. So this is one of the largest missions we have ever taken on. There's something really exciting that Perseverance is bringing along with it. It's actually bringing a drone. We're gonna fly for the first time on another planet. We've always known that you could fly on Mars. We've just been waiting for the density of batteries, the power density, and then the efficiency of electric motors to get to the point where you could. Today you can. So we're bringing along a little drone that may actually change the way we explore the red planet. So this is a very exciting thing we have coming in the future. I'm extremely happy to be here and being able to talk to you all remotely, as I'm sure you are also dealing with the fallout of the coronavirus and the pandemic. I hope you're all staying healthy and safe. I hope you really enjoy your Case Space School, and I look forward to hopefully meeting many of you in person in the near future.